If I told you you could save $100,000, would that get your attention? Well, now you can, with my hydroelectric turbine design that can be placed into the weirs of rivers and canals. Hi, my name is Colin Manfredo, and I'm from Sanger FFA. The purpose of my project was to investigate that if I can place a hydroelectric turbine into the weirs of rivers and canals, and that would end up being a viable source of energy. See, my goal was to prove that with the small drop from the weirs and the speed of the water, you would end up creating electricity and saving thousands, hundreds of thousands of dollars. See, the United States is predominantly a country that uses fossil fuels as its main source of electricity. There are over 250,000 rivers in the United States. So that can be wondering, well, why can't we be the leader of the whole entire world in hydropower? See, with my design, I can help with that. I learned throughout my project how to measure PSI with a 5-gallon bucket. I also learned that different types of weirs, canals, and rivers need different types of hydroelectric turbines. Another thing I learned is that hydroelectricity is a clean energy source. And the fact that you don't even need a drop to end up creating electricity. You can just use the flow of water itself. And the main thing I learned is how much the whole world could save with my design. I had the pleasure to collaborate with Mr. Jim Wegley, who is partner at the Keller Wegley engineering firm. And I also had the pleasure to collaborate with Mr. Chad Wegley, who is the Alta Irrigation District General Manager in Central California. They helped me throughout my project in showing me what kind of designs I could use and how I could create a theoretical example that could predict my savings in kilowatts. So, my results were that with a 5-foot drop in a river or canal running at 200 CFS, you will be able to save $100,000, and you'd be producing 1,400 kilowatt hours per day. This could run 46 homes. Now, with a 3.5-foot drop, you'd be saving $70,000, and you'd be only producing 1,000 kilowatt hours per day. Now, you see where I'm going here? The less the drop is, the less amount of savings you're going to have. And the higher the drop is, the more amount of savings you will end up getting. Now, you may be wondering, well, if your savings keep going down, what happens with the 0-foot drop? You'll still save money. With the 0-foot drop in a river or canal, running at 200 CFS, you will be able to save $20,000, and you'll be producing 250 kilowatt hours per day. See, in my small-scale model, I couldn't notice this because of the fact that I was having a small output of electricity compared to when I plugged it into my theoretical example. When I plugged it into my theoretical example, I was able to notice the difference between the savings from my 5-foot drop, my 3.5-foot drop, and my 0-foot drop. Now, this is still beneficial to farmers because of the fact that farmers are pumping water out of rivers and canals all the time to help with their irrigation practices on their farms. So you can implement my design into their pumping systems or how they get their water from the rivers and canals. And that would be a clean, new source of energy that can be produced for them. But now you're wondering, well, what is it just farmers this helps? No. This helps me, you, people in the city, people in rural areas. As long as you live near some sort of river or canal, you can be saving electricity. I would like to take this time here to thank you for coming to listen to my project. Have a great day.